Okay, this is L4, U4L4, and we're talking about rationalizing roots. Okay, so let's do a quick review on radicals, right? So here, this symbol is called the radical sign. What's under it, it could be a number or a string of numbers, is called the radicand. And there's this little space here in the corner of it. And usually we don't see anything there, but there's actually a space for a number there. That is called the index, right? The index of the radical sign. And we usually don't write any number there. So if it's invisible, we don't see anything there. The number is actually 2. Okay, there's an invisible 2 there. So that's what that number does, is that it tells you have to break your radicand into 2 things that are the same. Right, so here's a 9. I can break down to 3 and 3. 3 times 3 is 9. Right, that's how we get radical 9 equals 3, because the index is 2, so I break 9 into 2 numbers. Later on, you guys are going to see something like here's the cube root, right, the third root of 1,000. So I break 1,000 into 3 numbers, right? What 3 numbers multiply? The same number multiplied to itself give you 1,000. Has to be 10. That's why the answer for that would be 10. Or you can have like the fifth root of 64. So it would be 2 times 2 times 2, 5 times, and the answer would be 2. Okay, so that's just how, so you know how the radical symbol works. And let's talk about the properties of radicals. If I have radical A times radical B, I can put that together in the same radical as radical A times B. And it also works the same way backwards, right? If I have a thing inside the radical, I can break it into 2 things as long as they multiply to be that same number. So here's an example. I have radical 5 times radical 2. I can put that together as radical 5 times 2, which is radical 10. Okay, going backwards, I have radical 18, and I break that into radical 9 times 2. And I chose 9 because 9 is a nice number. I didn't choose 6 times 3 because radical 6 and radical 3 cannot be simplified, right? But radical 9 can. So I split into radical 9 times radical 2, and radical 9 is just 3, so 3 times radical 2. So that's how the property is helpful. And I have the quotient property as well. If I have radical A over B, that's the same thing as radical A over radical B. And how that works is if I have radical 1/4, that gives me radical 1 over radical 4. And that's helpful because radical 1 is 1 and radical 4 is 2. So the answer is actually 1/2. So let's use those properties to help us simplify the square roots here. I have radical 48 times, just radical 48, I mean 98. So I break this into radical 49 times 2. Okay, and I chose 49 because it's a perfect square. And you guys really should know your perfect squares, right? Make a list of perfect squares and hang it on top of the ceiling. So every time you go to bed, you see it. And every time you wake up, you see it. Okay, so radical 49 is a perfect square. Just like how 1 is a perfect square, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are perfect squares. You need to know those, okay? Make a list. So I chose 49. It's a perfect square. And that becomes just 7. So I have 7 times radical 2. Okay. Another one, I have radical 27 over radical 16. I can split that into radical 27 over radical 16. And radical 27 becomes radical 9 times radical 3 over 4, because radical 16 is 4. And radical 9 is just 3. So 3 radical 3 over 4. All right. Let's rationalize the denominator. Okay, this is the main idea of this lesson. So really try to focus on this part. If you have a fraction in your radical, can't have that, right? Someone decided we can't have fraction in your radicals. So I'm going to split that up into radical 5 over radical 2 like this. And again, that's a problem. They don't want radical at the bottom either. So you have to get rid of the radical at the bottom. So what I do is I'm going to multiply the top and bottom by that radical bottom. So I multiply top and bottom by the radical 2. So you see what happens here is radical 2 times radical 2. Remember, that is just radical 2. Okay, so here I'm going to multiply them like this, right? Top times top, bottom times bottom. And then I put them together because of the property that we had earlier, the product property. So I have 5 times 2 in the radical and 2 times 2 in the radical. And see here, the same number means you can bring it out. That's the whole point. The whole point is so you can simplify the bottom. So radical 2 times radical 2 at the bottom gives me 2 at the bottom. And on top, I get radical 10. I don't care about the top. The top is just radical 10. Leave the radical there. The bottom no longer has a radical, which is the point. And so the goal is to get rid of the radical at the bottom. And how we do it is multiply the top and bottom by that same radical at the bottom there. Okay. So another example here, I have radical 11 over 3. I split that up into radical 11 over radical 3, and I multiply the top bottom by radical 3 because that's the radical at the bottom. So I multiply that. And here I'm going to skip some steps, right? I'm not going to write out every single step anymore because I'm getting better at this, right? So this here, I know I can put them together. So I get radical 33 on top, and the bottom is just 3. Okay? And here is when it gets a little bit more complicated, and when we learn about something called the conjugates, okay? So before we do that, let's do a little bit of a review. I have x plus a times x minus a. And some of you guys might know this already, and you really should. If you don't, FOIL this out and see how that works. Okay, if I FOIL this out, I get x squared minus ax plus ax minus a squared. Okay, and you notice the middle terms here, minus ax plus ax, they cancel each other out. They go away. So I have just x squared minus a squared. So you have, whenever you have this pattern, a number plus a number times that same number minus the other number, that pattern, and you multiply them, you get square of the first minus square of the second. Square of the first, see, minus square of the second. Same thing here. I have that pattern. So I should get square of the first minus square of the second. So square of 5 minus square of radical 3. And you FOIL that out, you see that, see, the middle terms cancel each other out again. And then I have just square of the first minus square of the second. So square of the first is 25. Square of radical 3 is 3. So I have 25 minus 3. It's 22. See, the radical goes away because the middle terms cancel each other. It's kind of like an algebraic trick that we did. Okay, and then we're gonna so these guys are called conjugates, right? Because it's one is plus, one is minus, and they're the same numbers. Okay, they're conjugates. So in general, I have a plus radical b and a minus radical b. These are conjugates, and the nice thing about them is when you multiply them, you get rational numbers. See, 22 is rational. You don't have a radical in there anymore. Okay, examples. Let's simplify these square roots by using conjugates. First one, I have 5 over 7 plus radical 3. I have to use the conjugate of this, right? So I have 7 minus radical 3. I'm going to multiply that by the top and bottom. So what I get is 5 times that on top, but the bottom here is square of the first minus square of the second. See, square of 7 minus square of radical 3. So square of 7 is 49. Square of radical 3 is 3. So no more radical at the bottom. It's nice. But on top here, I distribute this in. I get 35 minus 5 radical 3. Bottom, I have 46. Done. Here is another one. Again, the conjugate of this is 4 minus radical 5. So there, I multiply by 4 minus radical 5. And, FOIL the top here. And not FOIL, but distribute the top. But the bottom is square of the first minus square of the second. See? Square of the first is 16. Square of radical 5 is 5. So 16 minus 5. Then you multiply that in, you get 4 radical 2 minus radical 2 times radical 5 is radical 10. So there, that's the result. Last one. Here, 5 minus radical 3. See, don't worry about the top. Just worry about the bottom. Do the conjugate at the bottom. I have 5 plus radical 3. So times 5 plus radical 3 at bottom and top. See, this one you have to FOIL the top out. See, but the bottom is nice. Square of the first is 25. Square of the second is 3. 25 minus 3, I have 22 at the bottom. So when you FOIL this out, you have 4 times 5 plus 4 times radical 3 plus 5 times radical 3 plus radical 3 times radical 3 is radical 3 squared. And the bottom is 22. Okay, and you see these middle terms here. These are like terms, okay, because you have 4 of radical 3 and 5 of radical 3. So you add these together, you get 9 radical 3. And radical 3 squared is just 3. So 20 plus 3 is 23. And the bottom is just 22. So 23 plus 9 radical 3 over 22.